How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 15.3, understanding and working with equilibrium constants. So our objectives will be to manipulate equilibriums and determine the resulting value for KEQ. You know, if we were to flip it, if we were to double the coefficients or combine equations, what do we do with those KEQs? And also infer if an equilibrium lies far to the left or to the right based on the magnitude of the equilibrium constant. Number one, the equilibrium constant for the reaction below, blank, there it is KEQ equals this at a given temperature. At equilibrium, well, let's take a look. At equilibrium, we know it can't be only products exist because that's not an equilibrium. We have both directions. So we're going to have products and we're going to have reactants existing. So A and B we can rule out right away. Products and reactants are equal. There are more products than reactants, or there are more reactants than products. Interesting. So we look at the value for KEQ and we see that it's times 10 to the minus 3. So that means it's really like 0.00623. So this number is small. It's less than 1. Remember, the generic like KEQ expression is the products over the reactants, if we were to make it overly simplified. So if I wanted something that was tiny, well, I need to have the products be less than the reactants. Because that way we have a small number over a big number, which will give me a decimal. So I'm looking for that option. There are more products than reactants? No, there are more reactants than products. Boom. Number two, the equilibrium constant for the reaction, here it is KEQ equals that number at a given temperature. At equilibrium, all right, same kind of thing, but now, hey, it's times 10 to the second, so it's really like 275 is my value. So again, if my equilibrium constant expression is essentially the products over the reactants, how do I get a big number? Well, I need the products to be more than the reactants. So which option is that? It is option D. All right, the equilibrium constant for the reaction A is K. In terms of K, what is the equilibrium constant for reaction B? So we know that this is K, right? And we go, all right, well, how do we go from A to B? What did we do to get B? Well, let's see. I have NO3 as a product here, but NO3 as a reactant there. So I know I had to flip it to get the NO3 on that other side. But also, if you look, the coefficients have been doubled. So I also doubled the coefficients. All right, well, when you flip the equilibrium, we know that originally it's products over reactants. If we were to change the direction of that equilibrium, we're going to change what's on top and what's on bottom. So we're going to end up with reactants over products. And if we're talking about it like mathematically, we could think of that as being the reciprocal. So I end up with 1 over K when I flip it. Now, if I double the coefficients, what's happening is like, hey, if these were to the 1, now I'm changing this to the 2. Whatever I do to the coefficients, I have to do to the exponent. So it's the same thing as if I were to double it, then I square it. If I tripled it, then I cube it. If I quadrupled it, then I'd have to put it to the 4th power. So when I double the coefficients, it's really 1 over K squared, which if you were to just write it out, it's the same thing as 1 over K squared. So either way you write it is acceptable. 4, the value of KEQ for the following equilibrium, there it is 598 at a given temperature. What is the value for KEQ for the following equilibrium? All right, so how did we go from this to this? Everything's still on the same side of the arrow, but if you take a look, the coefficients have been cut in half. So if this is my K, right, and I were to cut it in half, I have to do the same thing to the exponent. So I got to put it to the 1/2 power, which is the same thing as doing the square root. So I have to do that. Square root of 598 equals beep bop boop, roughly 24.5. And that would be my answer to that. Oh, and that was it. It was a short section. I hope you found it helpful. See you in class. Okay, bye.